So I just measured the weight of this piston. This is 200 grams. Now, just so you know what this is almost 1 3/16 of an inch in diameter. What I actually wanted was, because I deal with imperial measurements, I like to deal rather than with newtons, I like to deal with pounds per square inch. So while I have the ability to do this, I'm making a test rig, I decided to make this one square inch. So this is basically 1 square inch is what this is, just made into a round form. So it's almost 1 3/16. Yeah, we're somewhere in that area. Anyway, I'm going to take some weight off the back of this thing. My battery just died, by the way. I'm going to drill this out, and then I need to drill through so I can put a wrist pin in there. So it basically looks like a regular automotive piston. I was going to use brass, but I don't like the idea. Well, I was lazy and I didn't figure out what the expansion ratio of brass compared to steel was, and so I didn't want to. Well, I was just lazy, and besides, I wanted to see. I thought I had some metal that would work. I have this metal. I'd rather just use a steel piston for this particular project. So anyway, that's what I'm doing, and I'm just making a test engine. That's all this is just a test engine, so that I can see what I'm doing, so that I can put my steam generator under a load and then take some measurements with it. But I have to do all this work. Well, I want to do all this work so that I can have a good foundation to just continue on with my plans here. Anyway, I'm going to get busy and I'm going to machine this. I'm not going to film this. My batteries are acting up. But I'll show you what I've done. If you want to see someone that really knows how to machine, watch Cutting Edge Engineering, Australia. Look for it on the YouTube channel. You probably already have seen this guy. He's really a popular guy. I'm sure he does a good living on YouTube. I hope he does anyway. But I like him and his wife. I'm assuming that's his wife. They do great videos. I watch them all the time. So yeah, if you want to see someone do actual real good machine work, watch him. I just get by. I'm just lucky. I just saw 2 cats run by here. I'm just lucky I can get things built with the amount of patience and knowledge that I have. Anyway, okay. Okay, so I've drilled out the back of the piston. You can't see it, but there's a hole in the back. I did it in 3 different stages. I got about 2 ounces out of the weight of it, and I ran a mill across the top of the, oops, blew out. There, I ran a mill across the top of the piston to find my center, and I've drilled that. I'm going to drill that through probably about 1/4 of an inch hole, so roughly 6 millimeter for you metric types. Anyway, but that's with my little machine. That's how I find top and center. But and this is all whatever. But anyway, let's show you that. So I'll drill that out and drill all the way through, and then I'll show you what I've got. So that's my aftermath. I taped where I wanted to stop drilling, so I knew, well, so I'd have an idea of where I was when I went through the entirety of the piston. I don't want to drill into my little vise. So, but that's 1/4 of an inch hole. That should be plenty for the kind of power this engine's going to be able to put out. So I have the piston roughed out pretty decently. So there it is. There's the, well, yeah, you can see that. And you can see I did 3 different sizes of drill. The second stage in there is where I drilled my pin, my wrist pin. I guess it's a wrist pin. That's what I'm calling it. Anyway, it does fit in this cylinder quite easily. So we've got that done. I have my piston rings done. So we'll see what we've got. And my connecting rod will be the next step. But that's nice to get that done. I also took a fine round file and worked around the edges of the edges where the rings are, because I was thinking there's probably a good chance that there's some flash or some metal that had been pushed out on the edge. I mean, that's typical of a cutting, you know, that kind of a cutting like that, that was interfering a little bit with the ability of the piston, of the rings to touch. You know, what am I saying? There was flash that I got rid of. Anyway, I believe, so you can see there's like a little bit of a sparkle on those edges, and that's that beveled edge. Tiny little beveled edge, but I think it's important, like I said, that way if there were any little metal ridges or edges that were poking out, I wanted them gone, because what I want is I want the ring, the edge of the ring, to contact the cylinder, not the piston itself. So, but the piston carries everything, so, and a piston, well, whatever. Anyway, my compression area. And I'll probably even add a little bit to that, because I'll probably use a brass connecting fitting that can also add to that compression area just a little bit. But this gets me in the ballpark. So I take 0.17125 off of my 2.740, and I get my actual stroke, which is 2.56875. And that is giving me that 1/16 of an inch over here so that I don't run into my end. And that's also giving me my compression area over here. And like I said before, still have compression area, because inside the back of that piston, I've got plenty of room. So my actual stroke, which I've written down here in my really terrible handwriting, is 2.56875. Okay, half of 2.56875 is 1.284375, and that's important because if I do a single acting cylinder, right now I'm at the bottom of that stroke, right? There's the bottom of my piston, but when that piston moves all the way up here, this crank at this point will be halfway through the stroke, which means that if I'm connected to a flywheel, that's going to be my maximum angle. That flywheel is going to be like this, you know, it's going to do that, right? So when I go to half of a stroke, okay, well here, full stroke looks like that. Top dead center, my crank is right down the cylinder. By the way, the cylinder, I didn't have enough page to finish the other side of the cylinder. Let me back up and do this properly. So, okay, so full stroke is this. My rod is straight across, or straight through, and connected to the piston, and the piston is probably connected in here somewhere. Yeah, I've got a habit of looking underneath the camera. So then when I do my halfway stroke, I'll be like that. And now here's my center point roughly. Here's my extent, and I have just a tiny bit of room right here to clear the end of that cylinder. And that's what I want. That's my mid stroke. That's the biggest deflection that shaft is going to push. I have shaved, for what it's worth. I wanted to just do a real quick update. And by the way, I'm using a different resolution for this particular clip. I'm just playing around with a higher frame rate but a lower resolution. Here's my push rod, and the idea of my push rod is that it's in two pieces so that I can slip it through this center hole if I want to do a double acting piston. And so I align these up reasonably close. Well, anyway, we'll see how close they are. They're not great, but I think they're pretty close. We'll see what See what they look like. So I've got these welded in place and set up. You can see that they're level on the bottom and that they tilt on top, but that the bearings are right on the money. So yeah, that's what I want. I've just welded the one side, and as you can see, yeah, just kind of tacked them in place, clamped them down on the table like that, clamped them back here. I had this sitting out further. I always clamp this down so this doesn't drop on my foot, but I like using this as my welding table. Then I can use my pliers to clamp this piece down, and then I used to use a little piece of strap I had around here to clamp my little carrier down tight, and then I tacked it carefully in and then ground it down reasonably flat. So the idea behind that was that way I don't have anything thicker than my bearing that I have to account for. That's how I made this shaft, so that I would have, if I can get this in here, so that I would have extra out here to attach my crank to, and also to attach an output to if I feel like doing an output. So anyway, there's what I'm looking at, and I've got to do some machine work on that next, so that'll be my next step. Okay, it's time for an update. I've got a lot of stuff done here. I'm going to try to, it's just making sense just to show you, because there are a ton of other people who can do better work than me on the internet. And I understand that, and I'm fine with that. So, where to start? Well, we'll start where I think I left off. I was making these pieces. Let me get up here. There you go. So, that piece is now, that little piece of pipe has been welded on both sides. I MIG welded the back side, and I TIG welded this side just carefully. And and actually, when I TIG welded it, I had to really go through and I welded these, and then I cleaned up the interiors so that the bearings fit really nice and tightly. And then when I TIG welded, I didn't expect that I would have so much issue having to clean them up again. But I spent probably 30 minutes on each pipe, the interior, just carefully cleaning where I had shrunk or bent the pipes. But whatever, it's still, at the end of the day, that's a nice strong weld, and I may still have to cut some of that down to get my clearances right. But this is that. So that's a carrier. I also drilled these 1/4 inch. Yeah. Anyway, so I've done 2 of these. And here's the other one, mounted on a base. I decided I needed a base to mount these things on, so that I could do things like attach and carefully align everything. So that's what I've got going on here. So let me make this a bit safer. There we go. How is we looking? Now this piece is my shaft, and I'll just show you some of the stuff I've done. I actually haven't drilled it yet, but I've got it shaped so that the flywheel fits on it, and I did a little keyway right there. And actually, that's for a little cylinder, but I did that by hand, and that will hold this piece, which I just finished drilling. This will eventually be a bearing or a crankshaft, I mean, and so it will fit something like that. And then I'll do the same thing on the interior. I'll put a little keyway in here so that I'm holding it properly. I may also put some sort of clamping. I don't know. We'll see. I'll show you what I've got. But anyway, so let's go to this piece. So this is my big weight. That piece sits in. What I'm planning on doing back here, I need to drill a couple of holes, maybe 3 holes, and put some screws in here. And what I'm thinking about doing is just drilling the hole so that the edge of the screw will overlap onto this old cast iron piece, just a tiny bit, to clamp it in place. That way I don't have to do any damage to this old wheel. Not that it's a big deal, but I'd rather not do any damage to it. You know, like drilling it and tapping it, things like that. I'd rather just leave it original, intact. So, when I get this all put together, at this point, there we go. Go. So I've got that. I'll grab the camera in a second. With this piece preferably that. So something like that. Then this piece will sit over here and carry the cylinder. Let's bring her back a bit, which will be something like that. Well, here we go. Let's just do it that way. So something like that. That's the idea here. Let me just pick the camera up and show you now. But I thought I'd better do this because I'm sort of getting ahead of everything. And I'll clean these up a little bit, but that works quite nicely. And it's nice, it balances on the grease zerk here. When I have it set up, it balances down on the grease zerk, so that's really good to see. This has probably been on the lathe, but you know, it was a nice casting, that was certainly for sure. I guess I can back this up a little bit. Anyway, so the plan is to build this. Now I may weld a little piece on top of here once I get this done, and if I do, I'll have to make sure that keyway is available. Well, maybe not. The idea though is that I might want to clamp it against the shaft here, but I did have an issue trying to get that shaft square. So we'll have to see. But the idea is when I'm done, I'll have a crank. I'll have a crank pin that I put on this. Now this is going to go onto the lathe, and I'm going to define the circle, and then I'm going to take my grinder and cut these pieces, the corners off, and then I'm going to turn it into a circle on the lathe. So anyway, that's kind of what I got going on here. This is just a stand to get the piston up a little bit up higher, and I want it, like I said, somewhere in that area. And I'll bolt it down, and then I'll put this whole thing on a wooden pad so that I don't have to cut any of these bolts off. I don't want to do that. And that allows me to have a little bit of room back here. So when I get all this worked out, I want to put a little generator here. So I just swung this piece on my lathe, and using my little cutoff tool, I just made a nice little circle. So let me show you my cutoff tool. You know, it's funny, I bought this lathe, and it was actually pretty expensive when I bought it for a Harbor Freight lathe, but I'm so impressed with this little machine. I've upgraded it. The motors are all gone. I put a 2-horse motor in the milling side, and I've got a, I think it's a 1-horse motor, but it's a DC motor. They're both DC motors so that I can control the speed, which is great. Anyway, so this is my cutoff, homemade little cutoff gadget that I used to do that. But anyway, I am now gonna get the grinder out and do the nasty cuts with the grinder. Actually, I decided to do this on my bandsaw. Cut these ears off. A lot cleaner and quieter. Anyway, I'll get that job done, but I just wanted to show you. I don't mind cutting with my grinder, but it's noisy and dirty. Alright, so I cut the ears off with my bandsaw. So that's pretty nice looking. Alright, I'll go clean this up now on the left. Okay, so here's my piece. It started out looking like that. This was just the other side of the piece. I had a 6-inch wide, or yeah, I think a 6-inch wide or 7-inch wide, whatever. And I thought I'd show you how I'm cutting my little keyway. This is handwork, like most of the stuff that I do. So you see there's a little sawed in there. Just there's my finger for. Here is what I'm using to start this with. This is a little cold chisel that I've cut down, and when I get it, I've got 3 different chisels here, all to do slightly different jobs. I mean, but anyway, that's how I get started on my cut. Then I'm finishing it, this particular cut anyway, with, let's see which one, probably the one right under my thumb, probably that diamond bit. So just to show you, and so I'm just hammering. I mean, this is just like chiseling wood, but I'm chiseling metal. So anyway, you probably wondered about that if you've never done this. And there are other ways I could file this. I mean, this would be, I could file it or cut it with a saw, with a, well, with a jeweler's saw. Well, that thing is pretty giant. But really, at the end of the day, chiseling it'll work pretty well. So, but I just wanted to show you. Like I said, I'm kind of changing my ideas about how to do this filming. I mean, a lot of these things you already know how to do, or you can find someone who knows how to do them a lot better than me. And a lot of it is my issue with the camera going off in the middle of the thing that I'm doing, and that's annoying me. It's not the camera's fault either. It's the battery's fault. But anyway, so that's what I'm doing. I just wanted to show you, but and you can see just how small these chisels really are. But they were all cold chisels that I have ground down to the shape I needed. And I grind them, I keep them really cool when I do that. So anyway, okay. Okay, so I'm going to show you how I made my little pin. There's the little pin right there. You can see it. Oops. There it is. Here is a drill bit. What I did was I picked a drill bit a little bit larger than the hole that I made once I lined these up, and I drilled that out very carefully. Then I took the drill bit out, turned it around, and I cut a length of the drill bit off and put it in that hole. So now I've got, it's not perfect, I might do it again with a bigger size drill bit, but for now it's not bad. It's a little wiggly, but it isn't bad. Oh, and I need to turn that around. Okay, so we're starting to get a little bit somewhere here. That's looking pretty good. You can see that that wheel is a little wobbly. Let me show you something here. This, see, it's a little bit loose here. Well, now that I have the one part of keeping things aligned, taken care of, having that key in there, and I might make a bigger key, although I'm not unhappy with that key, quite honestly. It's pretty nice, but it's a little bit loose. I could probably do a bigger key. Still, the concept is great. I could have probably just put that together and drilled that rather than gone through the trouble of cutting it, right? How am I doing here? Anyway, so what I want to do next is I want to tap that probably a 1/4-20, just a 1/4-20, and the same on the other side, tap it a 1/4-20, because my shafts are kind of short. But I have a plan. I think I can make everything work okay. What I want to do here is, because this wobbles just a little bit, you know, it's kind of loose. You know, you can see it a little bit loose. I don't like that. So if I weld a piece of like an 1/8 inch thing, just an 1/8 inch piece of steel on here, and drill a hole in it, well, drill a hole in it, whatever I need to do. The idea though is that then when I bolt this wheel down, I'll bolt this flat to this. Now, I don't know for sure that's square or not, but if I have an issue, I'll be able to square it up, and I'll be able to firm it up quite a bit. And so that'll hold it true, as true as I can get it without it wobbling, right? Because I'll have a piece welded on here and it'll be bolted in tightly. And then that little key right there will keep this shaft from turning on this shaft. But like I said, I'll probably make it a little bigger. I'd rather have to kind of hammer that key in there. But then again, I need to take this a step at a time. And keep in mind, this is just my little test engine. It's just a test, you know. But it should be made so that I can change things out as I need to. So I just finished my weld. I realized that what I did was that's hot, put a washer up here, and I mean, it's basically centered, and I've got washers stacked up here so this is snug, so that washer is tight. And I love that, other than the fact that I did it on the wrong side. Now, I caught it halfway through it and then realized, well, I can just machine the other side if I really need to have that clearance, so I'm not too concerned about it. I've got plenty of metal there. And it might even be better to have this side just a bit recessed anyway, because I'm going to have a crank and potentially a cam here, so that might work out really good. Anyway, okay, but that's tapped. I tapped both ends and tapped them to a 1/4-20, and that's a grade 5. Okay, so this is where I'm at. I just got this put together, and you can see that's running pretty damn true. So I'm happy with that. So the idea was that this bolt holds this tight into this pin, into this cylinder. So now this is all a nice stable assembly. And that's the wheel spinning out on that. I still have to attach the wheel to it. But one step at a time, as a wise man once told me, a few days ago actually. So anyway, that's pretty good. I'm about ready to quit. I need to stop and take all these tools and put them away. It's a mess in here. And I had my brother-in-law stop by and brought me a lawnmower, which I really do need. I'm gonna have to work on it. I wanted an old lawnmower that had a metal carburetor because I don't like the plastic carburetor models. Now, if you take a look at that, look how nice that balances out. There's a little boss where that grease zerk is attached to, and so there's a bit of extra weight there. And it's nice to see that this thing is lined up decently enough that it is actually trying to find, it's finding its heavy spot. Okay, I took my connecting rod apart. I don't know if you've seen the top, but it's like a little, well, just what it ended up being. I made it a little bit more round. Yeah, and we'll see how that's going to work. So anyway, I'll put this together now. All right, so this is nice and loose now. Notice it hits up against the edges of the piston. So yeah, I like that. Okay. Well, okay, I'll continue on then. So yeah, I'll just keep checking in. My next step will be to get these guys tapped. It'll take some time. Whatever, has to be done. Ready to call it an evening. So I have made these little guys with some, just basically some 1/4" rod that I got downtown, and I've got an issue. I don't know if you can see this or not. Look, the thread is missing. It broke the thread off completely in an area. Now I plan on welding one side of these. That'll probably be the side that I weld. But I don't like that. I have not ever had that happen to me before. Now, well. I don't know if you could hear that or not, but that's the sound of this thing compressing. So, yeah. Yeah. Oh, excuse me. Okay, I thought I'd do one more quick video. I think I'm going to go ahead and try to make a video out of this though, because we're at that point where I think I can. So I'm just doing a little test here. This is just 10 pounds of pressure. I got it dialed down. So it's doing what it should do, in case you didn't see that. Let's see here. I don't know where let's try just a little bit more there. There we go. Here we go. Looking for my smart glasses that make me look smart, I guess. I don't know. So I wanted to do an update on this engine. So when I come in here, I need to grab some airline. Oh, by the way, this, can you see that? Let me back up a little bit. This is a vintage compressor. This is almost a collector's item, and it was built by a guy who's built things that you have probably seen, but you don't know who built it. And when I talk about things, I'm talking about pretty big, amazing things. So he built this for me, and this thing sounds beautiful. When it runs, it's a beautiful, beautiful sounding machine. Now I can't remember the brand name of it, but it's a very desirable machine. And anyway, he just did a beautiful job. I mean, look at the way he bent the copper. It's beautiful. Everything is beautiful. It's like, you know, the guy is good, and he's, like I said, you've probably seen some of the things that he's done. Yes, I know my camera's not wanting to. So I've got my regulator set. I have an external regulator on this set at 30 pounds, and I have just been setting. I set it up, and then I took a bit of a video of it. But let's see here. There we go. So that's what I wanted to show you. I'm able to get this thing with 30 pounds to roll all the way over. And there's still some tightness in here somewhere. I mean, this bushing is really tight. And I love the fact that it's really tight, but it may be pinching a little bit or binding just a tiny bit. I mean, I can feel, well, actually it feels pretty good. Well, right in there, it feels a little bit. We'll have to look and see what's going on. I'm going to call this good. I'm completely happy with this, other than I'd still need to play around with it and figure out why it's tight right there. And that could be the push, it could be a bunch of things, but I'll figure it out. I want it to be smooth. I want it to be like that, because I love that. That's great. But down here, yeah, you can see it doesn't want to do that. Now the steam will still push it, and the air pressure will push it through that rough spot. But if it's got a rough spot, it's not right. It needs to be. I need to get that worked out. Anyway, there's my update. That's coming along really well. I've got things to do, but so I've got that part of it roughed out. I've got this part of it getting closer, and I have to go make money so I can pay some bills. So I'm going to be busy for the next couple of days, and I'll see you when I get back.